Hello and welcome. My name is Piper Rushton. This is the final project for the Intro to Computer Systems class. So the overall concept that I submitted was a client-server based model where the client sends the server a file containing a list of numbers that need to be sorted. And the server, when it receives that file, it then takes those numbers and uses three sorting algorithms to try and sort them. Specifically, the server is using multiple threads to try and optimize the sorting algorithms. And once it has it sorted, it will calculate the time it took to sort those numbers and send the times back to the client, as well as the sorted list or a file containing the sorted list back to the client. So the way I went about this is I started with the client, in which case I had it connect to or try to connect to a server on the port. And once it connects, it'll get a file name from the user. It'll send that file name over and wait for the times that it took to sort. When the server will be created with a socket and wait for a connection. And when it gets a connection, it will split. Where is it? Oh, it will fork so that it can accept multiple users at the same time. And it will call the server function. So here I read the file name from the client and check to see if it works. If it doesn't, I'll return and say, hey, the file doesn't open, and exit and drop the client. And we will open the file, this file right here, and store all the numbers in a array, with the maximum being 500. So once we have the files initially stored, we will create a separate array so that we can keep the original numbers how they were. Where is it? Here it is. Okay. And once we have that array created, we will then go to make our threads. We will actually use a thread to call a function, specifically the merge thread function, where this is provided a left and right arguments in these left ones. So this is going to be, the left is going to be the minimum, the leftmost number, as we can see here in the merge sort. So left is going to be like the 38, or the first value in the array, and the rightmost is going to be the last one, or the 10 here in the array, the last element. So once it gets those, and it will go to calculate a middle where it needs to split at. First, it'll check and make sure that they're not the same number. If they are the same number, then that means it's time to return so they can be merged together. Because if it's this way, then that means that it's done its job, because this is just the splitting part. So once it calculates the middle, it'll assign the left arguments with the left argument, like here would be, it's not a good one, there's this one. So the left argument here would be 7, and the right argument would be 16, which is the middle, which is would be like around the middle because it rounds down. And then the thread that handles the right, it would set it to the middle +1 because the middle rounds down, so 24, and then the last element, which is 9. And then this will recursively call this same function, this same thread creation function. So it will continue to split and split and split until, like I said, with the if right here, until the two numbers on the ends are the exact same, which would mean it's either the same number or ones that don't need to be sorted at all. Once this occurs, it will then call the merge, which basically takes them and compares them. If they need to be switched, then they'll all but they'll get in the right positions. And this entire time I used this clock function, this clock library, to grab the time. I noticed very quickly that the times that this was taking, at least without the threads, was in the milliseconds. Less than milliseconds, actually. It was taking about around 30 processor ticks, which is not very calculable. So I had to use the processor ticks. Now, this was the optimization that I made for it. This was the best optimization I could really think of, and after asking quite a few people, it was kind of the best I could come up with. However, let's see here. When I go to run it, so here it's asking for the user input. When I go to run it, you will see that it takes a lot longer. A lot longer. And because without the optimization, when I tried it with just the normal merge sort algorithm, it would take around in between 40 to 50 ticks. But here you can see this is thousands of times magnitude. And okay, so why is that? I as you can see, I did not fully implement it with quicksort or insertion sorts. And I will go over that in a second on how I would have and why I didn't. So I got stuck here because clearly there was something wrong. This is a huge number and it is de-optimizing it where I should have been optimizing it. And I got to thinking and I got to asking a bunch of people about looking up solutions. And what I had found, or the conclusion that I had come to, my theory, is that the time it's taking to sort it is already so low. Each step inside of these recursion branches is already within sub-milliseconds. And it is taking more time to create and join the thread than it does to actually sort the numbers. So you'll see, that's why you see these huge jumps in time. Now, I personally could not think of a way to fix that because I think the very notion of sorting, maybe there was a better way to go about it. I could not find one. As far as I can tell, it is actually makes it take longer to implement it here. Now, as far as quick sort and insertion sort, as you can see here, this is the example of a quick sort. It's kind of the same thing as merge sort, except without the first half. So it'd be fairly easy to implement it in a similar way. And the reason I didn't do an insertion sort is because it's actually kind of impossible or not optimal at all. As you can see, each step is linear. It's really hard to do this what's it called at the same time, these steps at the same time, because they require the step before them to be done. So this is why I didn't implement them. This is where I got to, and honestly, I think even if I were to implement merge, it would still end up being quick sort with threads. It would still be the exact same thing. So yeah, I guess threads are not the best for sorting algorithms.